Ever found yourself questioning why Python tops the chart as the most used programming language? If so, you're not alone. Python's popularity is no fluke. It's user-friendly, versatile, and powerful, making it a go-to choice for many programmers worldwide. Python's simplicity is a game-changer. Its clean syntax and readability make it a fantastic choice for beginners and experts alike. But don't be fooled by its simplicity. Python is as powerful as it is user-friendly, capable of driving complex applications and systems. Its versatility is another key to its popularity. Python is prevalent in various industries, from web development to data science, artificial intelligence and more. Its wide-ranging applications make it a practical choice for any project, big or small. But the real beauty of Python lies in its thriving community. It's an ever-growing ecosystem that continually contributes to its development and advancement. Now that we understand its popularity, let's delve into the basics of Python, starting with data types. Python, like any other language, has a vocabulary, the data types. Let's dive into the world of Python data types. First up, we have integers. These are whole numbers, no decimals, no fractions. So 5, 20, -3, 0. These are all examples of integers. In Python, you don't need to declare the data type of a variable explicitly. The language figures it out on its own. So if you assign a whole number to a variable, Python understands that it's an integer. Moving on, we have floating point numbers or floats. These are numbers with decimal points. For example, 3.14 minus 0.01 or even 0.0. The term floating point refers to the decimal point which can float among the digits of the number. Next in line we have strings. Strings are sequences of characters. They can include anything, letters, numbers, symbols, spaces, and even the empty string, which contains no characters at all. In Python, you can define strings using single, double, or triple quotes. Last but not least, we have booleans. This is probably the simplest data type in Python. A boolean can have one of only two values, true or false. It's named after George Boole, who first defined an algebraic system of logic in the mid-19th century. Booleans are used to represent the truth values that are associated with the logic branch of mathematics, which is fundamental to computer science. Now you might be thinking, that's great, but when would I use these? Well, every time you write a program. If you need to count something, use an integer. If you need to measure something, use a float. If you need to print a message, use a string. And if you need to make a decision, use a boolean. These are the basic building blocks of Python. But to construct more complex and interesting programs, we need to learn about data structures. Think of Python data structures as the grammar rules of this language. Let's dive into two fundamental Python data structures, lists and tuples. Both of these structures are used to store collections of items. However, they serve different purposes and have distinct characteristics that set them apart. First, let's talk about lists. A list in Python is like a shopping list. You can add items, remove items, or even change items. It's mutable, meaning it can be altered even after its creation. This makes lists incredibly flexible. For instance, if you have a list of your favorite movies, you can easily add a new release to the top of your list, or remove a movie that, upon rewatching, didn't quite stand up to your nostalgic memories. Now on to tuples. Think of a tuple as the coordinates of a point on a map. The order matters, and you can't just change them. Tuples are immutable, meaning they can't be changed after they're created. This makes tuples ideal for storing information that's not meant to be changed, like the keys on a keyboard or the days of the week. So how do you choose between lists and tuples? Well, it's all about the nature of your data and what you intend to do with it. If your data is likely to change or needs to be sorted or rearranged, a list is your best bet. But if you're dealing with static data, where the order and content are fixed, then tuples are the way to go. Let's illustrate this with an example. Suppose you're managing a team of software developers. The team members might change over time, so you'd store their names in a list. But the roles within the team, like front end, back end, and full stack, are fixed, so these would be stored in a tuple. Lists and tuples are just the tip of the iceberg. There's more to explore in Python's data structures. Continuing our exploration, we now delve into sets and dictionaries. Sets in Python are akin to mathematical sets. They contain unique elements and are unordered. Imagine you have a collection of distinct elements like a bag of unique marbles. That's a set. They are highly useful when you want to eliminate duplicate values from a list or to test membership. Moving on to dictionaries, think of them as real-life dictionaries. Just like you have a word and its meaning, Python dictionaries consist of keys and their corresponding values. The key-value pairs make dictionaries a vital data structure for data organization and retrieval. For instance, if you're making a phone book, the names would be the keys, and the phone numbers would be the values. One unique characteristic about sets and dictionaries is their mutability. You can add, remove, or change elements after the set or dictionary is defined. But remember, while sets can't have duplicate elements, dictionaries can't have duplicate keys. Now, when should you use them? Sets are great for membership testing and eliminating duplicates. Dictionaries, on the other hand, are perfect when you need a logical association between a key and value pair. And with that, we've covered the fundamental data structures of Python. Python, with its user-friendly syntax and powerful capabilities, is indeed a favorite among programmers. We've journeyed through the reasons behind Python's popularity and delved into the nuances of its basic data types and data structures. From integers to lists, dictionaries to tuples, we've covered the gamut, laying a solid foundation for your Python proficiency. With a firm grasp of these basics, you're now well on your way to mastering Python. Remember, practice makes perfect, so keep coding.